Hello students, in this session we will discuss about polynomial equations and how to represent it in terms of linked list concept. Now when we observe the general form of a polynomial equation, so this equation can be represented as p of x equivalent to a suffix m minus 1 x power e suffix m minus 1 plus a suffix m minus 2 x power e suffix m minus 2 plus and so on a suffix 0 x power e suffix 0. Here a suffix I values refers to non-zero coefficient values and e suffix I values refers to exponent values. Here the largest exponent of the polynomial equation is known as its degree. Now observe this example. Here p of x is equivalent to 3x power 14 minus 7x power 8 plus 1. Here the highest exponent value is 14. Hence the degree of this polynomial equation is 14. Okay. Now a polynomial equation is possible to represent in terms of arrays and linked list. In previous classes we are familiar with how to represent a polynomial equation using arrays. So in this session we discuss the polynomial representation using linked list. Here observe this one, polynomial representation using linked list. So to represent any polynomial equation in terms of a linked list, first we create node format. So here node consists three parts like COEF, EXPO and link. So here COEF field stores coefficient values, expo field stores exponent values, link field stores address of the next element of the list. Now observe the structure representation of this node. Here the node is created with the help of self-referential structure as typedef struct list open brace int coef coefficient comma expo exponent struct list asterisk link and curly brace. Now this entire data type is referred with a new name as polynode. So for this data type polynode, it is possible to create any number of nodes. Now observe this example. Now consider the polynomial equation p of x equivalent to 3x power 14 minus 7x power 8 plus 1. When we observe this equation, here three elements are available. Hence, to represent it in terms of a polynomial equation using linked list format, here we design three nodes and each node consists coefficient, exponent and link parts. So for the first element, coefficient is 3, exponent value 14. Now link part shows address of the next element. Here for the next element, minus 7 is the coefficient value, 8 is the exponent value and link part consists address of the next node. Now for this next element, coefficient value 1, exponent value 0. Here the next element is not available. Hence for this element link part is filled with null pointer. So it shows linked representation of a polynomial equation. Now, polynomial addition operation. So to implement this operation, assume there are two polynomial equations P1 and P2 with the degree values as D1 and D2. So polynomial equation P1 with degree D1 and a polynomial equation P2 with degree D2. Now, to implement addition operation, first identify which is the highest degree from D1 or D2. Now based on the highest degree value, now assume the highest value as D3 and it forms the resultant polynomial equation P3. So P3 is a resultant polynomial equation with a degree value as D3. Now here, when we apply addition operation on these two polynomial equations, now it falls into three cases. Like case 1, if D3 value is greater than D1, then simply copy the node information of second polynomial equation into resultant polynomial equation and immediately move the pointer to next node. Case 2, if D3 is greater than D2, then simply copy the node information of the first polynomial equation into resultant polynomial equation and move the pointer to next node. Now case 3, if D3 equivalent to D1 and D3 equivalent to D2, the same degree is available. Now add the coefficient values of first polynomial equation and second polynomial equation. Then copy the resultant value into the result polynomial equation and move the pointer to next node. Okay, so in such a way it is possible to apply polynomial addition operation. Now, circular list representation of polynomial equations. Students, you are all familiar with circular linked list concept. In circular linked list, link part of the last node is filled with address of the starting node. Hence, when we observe the circular linked representation of a polynomial equation, here the link part of the last node is filled with null pointer. Now it shows a diagrammatic view. Now assume this one polynomial equation. So this equation has three elements. So we need three nodes and these are linked in terms of a circular fashion. So here the link part of the last node is filled with address of the starting node. Thank you.